Welcome, I am Pierre Senelard, and in this video I will demonstrate the use of a probabilistic database in an image retrieval application. More specifically, we will showcase ProvSQL. ProvSQL is an extension to the Postgres database management system that adds support for management of provenance and for probabilistic databases. Here, we use it to query uncertain data in the form of uncertain annotation on objects present in images to build an image retrieval system. We use the COCO, or Common Objects in Context 2017 dataset, a standard dataset used to evaluate image detection models. We have taken this dataset, augmented it with degraded pictures to better showcase uncertain data, and used the YOLO state-of-the-art image detection deep learning model to detect objects in these images. Let's look at the interface of our system. We can issue queries to look for images that contain any of the objects from the COCO dataset. Let's look, for instance, at for any image that contains a bird, a cat, and a dog. We click on the search button, and we obtain the resulting images, so 44 of them, ordered by a decreasing probability, including the top result here, which is indeed a picture containing these three elements. Detected items are sorted in decreasing order of Shapley value, of expected Shapley value more precisely, which is a measure on how important they are for the query. So we find the bird, the cat, and the dog. Here, all three are equally important. They have a expected Shapley value of 14%. This means that we need all three of them for the query to be satisfied. Other elements that are not in the query have expected Shapley value of 0 because they don't contribute to the query. We also see the annotation of each item. So this is the confidence that is provided by YOLO, and it's a measure of how much YOLO is confident in the annotation of this item as this category. Here, for some reason, it's much more confident that the bird is in the bird with 85% probability than the dog is a dog with only 65% probability. Instead of doing a probabilistic query evaluation, we can do a regular query by clicking on this button, which will just filter out every object that has a probability lower than a threshold, and here the threshold is 50%. So with a threshold of 50%, we only get this same image, which is the only image that matches the query with this particular threshold. And if we considerably lower this threshold, if we take a threshold of, for instance, 10%, and we run the query, then we get more images. We get 14 images, but including wrong results. So this is an image which is a degraded image from the YOLO dataset, from the COCO dataset, where YOLO predicts incorrect objects. Here, so for instance, one of the cats, the one on the right, is detected to be both a dog and a bird, but with low probabilities. Okay, so now let's look at another example with a more advanced query. So I want an image that contains at least two buses, so 1, 2, that contains a clock face, and that doesn't contain a bench. So I'm going to use this button to say I don't want a bench. So why no bench? Well, because, for instance, I don't want a picture of a bus stop, which would probably have a bench. So again, I issue the query, and I obtain the results, 45 in totals. I can also look at not just the raw number of results, but how many results are expected to be in the results based on their probability, so only 16 around. And this is according to YOLO annotation probabilities. Let's look at the top results, this one. So it is interesting to note that its probability of being correct, 91% here, is greater than the probability of either of the two clock annotations. So this clock has a probability of 89%, this clock has a probability of 62%. We have a higher probability of the image to be a valid match to the query, so in particular to contain at least one clock. Well, since we need only one clock and annotations are assumed to be independent, the probability that one of them is correct is much higher than the probability of either. This is the same for the buses, where we have 3 buses in the image to choose from to get the 2 buses that we required in our query. We can also see that Shapley values differ, contrary to the previous example. Here, the Shapley value, for instance, of these 2 buses are higher than the Shapley value of this particular bus. This is the expected Shapley value, and since this bus has a lower probability, it's expected that these 2 buses contribute more to the query than these particular buses. And since we have a similar phenomenon with the clocks, where this clock contributes more to the query than this particular clock, because this particular clock has a lower probability. Now let's look at another result. Let's look at a result 31 for the same query. So it has 2 buses, one here, one there, which is a bit hidden, and we are not completely sure it's a bus, but YOLO predicts it's a bus with a lower probability. It has 1 clock here, but it also has actually 1 bench here. So why do we get this result even though it has a bench? Well, because the probability detected by YOLO for this bench is not 1, it's 26%. So there is a probability of 74% that the image actually doesn't contain a bench. And so this is taken into account in the probabilistic query evaluation. But these are the consequence. The bench contributes negatively. You can see the negative expected Shapley value here. The bench contributes negatively to the overall image, or to being a match to the query. And the overall probability of the image is actually lower, with 21%, than the probability that this image would match a query that doesn't require the image not having a bench. It would be, in this case, around 28%. So to conclude, let's look for another example with a picture with 2 couches, 1, 2, with a microwave oven, with a ball. So let's search by probabilistic query evaluation and see what results we obtain. So here the top result is indeed correct. We have a microwave oven, we have 2 couches here and here, and we have 1 ball here. It's fine. So the probability is fairly low because YOLO is actually not very confident in these annotations. Especially, you can see that the probability that this is a ball is only 33%, which is fairly low. So we can look at the other results to the query. This one is also fine. There are 2 couches, 1, 2. There is a ball, and there is a microwave oven in the back. This one is actually also fine. It's a degraded version of the first image. And this one is also fine. It's another degraded version of the first image. If you look at the last result, there are 5 results in total. This one is actually incorrect. It predicts that there is a microwave here. If you look carefully at the image, it's actually not a microwave. So this is a wrong annotation. YOLO has a lot of trouble on this image because of the degradation on the image. Okay, but for probabilistic query evaluation, the top results are actually correct. Now let's look at the search by probability threshold. With the threshold 10%, we get 3 results, and they are all 3 good results. But we are missing one of the good results, which was one of the degraded version of this image. And so we need to lower the probability threshold to get this 4th result. So let's set it to 5%. Here we do get this image, which is a valid result. But the problem is that with this threshold, we also get the wrong image. And actually, there is no way of setting a threshold here that would get all 4 correct images and not get the 5th image. Okay, thanks for watching.